So Wednesday, you were tasked with reading about properties of logs, and I did check with your Algebra 2 teachers, and this is something that you guys did last year. Now, it's been a while, so probably not super fresh in our minds, but my hope is that after looking through some examples and taking some notes, we got what we need from that. So let's check and see. So if I gave you a problem on a test, let's say, I want you to write this down in your notes, or you can just do it at the bottom margin of your scratch paper, homework, whatever. If I were to give you a problem with, let's say, the cube root of x and a y squared and let's put a, sorry, I'm making this up as I go along. Let's make that 4y squared on the bottom. Would you be able to split this up into multiple logs, addition, subtraction, no exponents or radicals in your final answer? Do you feel confident that you could do that? So if I were doing that, probably my first step would be to recognize that this cube root can be written as an exponent. Are we comfortable with that? So what would my exponent be on that x if I didn't want to write it as a radical? Cube root's the same as 1/3, power of 1/3. Awesome. And you know that if we have multiplication inside of a log, that turns into addition. If we have division, that turns into subtraction. When I look at this, I see we're dividing by two different factors. So I'm going to be subtracting two different logs here. You see how there's two factors down there? So if I split it up at this point, I would have the log of x to the 1/3. And then what's going to be the sign on my log of 4? Plus or minus in between? Minus, because we're dividing by 4. We're also dividing by y squared, so we'll also have minus log y squared. So far, so good. And the final step, are you comfortable taking these exponents, pulling them out into the front to get 1/3 log x minus log of 4 minus 2 log y? If we're feeling all right about that, then we're in good shape. Could you go the opposite direction? If I gave you this, would you be able to put it back together and make it look like that? That would be the other piece. So I need you feeling pretty confident going one way or the other. And then the other big thing that I need you to know is the change of base formula. So if I am working with the log base 2 of, say, 7, and it would really be way more convenient for me to be working in a different base, do you know that you can change the base? Let's say I'm working on a problem. Let's say I'm in calculus, okay? And it would be way, way more convenient if this were a log base 3 instead of a log base 2. Do you know how you can make that happen? Well, you can rewrite this thing as the log base 3 of 7 over the log base 3 of 2. The whole change of base formula says that you can turn any log you want into another base. Doesn't matter which base I use. The book used common log, or they use ln. But what I need you to know is that you can use any log base you want, okay? So in your homework, they're going to ask you to evaluate some of these things, and you can evaluate them with using the common log or the natural log. By the way, your calculator likely has a button that you can type this in directly. That's all fine and good, but I'm going to ask you on the test to show me your work using change of base formula. So getting an answer to this will get you half credit. Showing that you understand that you can do it as log of 7 over log of 2 will get you the rest. The other thing that I might ask you on a test is to write the log base 12 of 63 as a log expression with base 2. This would be a really quick and easy problem on a test if you knew what to do, right? You know what to do? What are you gonna? We're gonna make a fraction, right? You're gonna have a log on the top and a log on the bottom, and I'm asking you to write it with log base 2, so we'll put log base 2s in there. And up here, I'm gonna have a 63, and down here, I'm gonna have a 12. That's it. That's all you need to do. Okay, so that change of base formula is useful for evaluating using a calculator, although your calculator probably, you can just type this in. Most of the calculators, you can just type that in. Some of the school calculators don't have that feature on it, but that's all right. Honestly, for as much time as it takes to find this in my calculator, to go to the math menu and find it, it's actually quicker to do it this way in the calculator. But I also need you to know that you can use the same thing. It doesn't matter what base you put on these logs. If you put it in the fraction and the thing inside's on the top and your base is on the bottom, you can choose any base that you want there. You'll use that in Calc to make things into bases that are more convenient for you. All right, so that's kind of the short version of our notes from that section. Did anybody have any questions from 3.4? That was our assignment on, started on page 317. I'll be checking this later today, but does anybody have any of those problems that we can go over? You guys were able to do them. You're feeling successful about them. Check your answers. I think I assigned mostly odd problems again, didn't I? So you had an opportunity to check your answers. Questions? No questions at all on it? All right. What about 3.3? You haven't had an opportunity to ask questions about that assignment yet. Can you look at that one for me, please? I will be checking this one a little bit later as well. It starts on page 308. That's the one that started on page 308. It's a pretty short assignment. Again, all odds, so I hope you checked. Yeah. Number 5. Yeah, thanks for asking. Number 5. So we're going to evaluate the log base 5 of the cube root of 25. So on the review that you're going to be doing, I'm going to ask you to do something similar to this, and I'm going to ask you to show work. There's several different ways you can show work for this, okay? So some of you would be most comfortable turning this into kind of thinking about what we talked about in terms of translating what this log is. Remember, I taught you last time I saw you on Monday, I taught you logs are exponents, right? And what I'm really asking you for here is the exponent I could put onto a 5 to make it equal to this thing, right? So some people have been showing work by doing this. 5 to the blank equals the cube root of 25 and figuring out what that exponent is. That would be a valid way of showing work. Okay, and then to do that, I'd probably do some work on this slide. I'll come back to that in a second. Oh, actually, let's just do it right now. So what we might do here is think about anytime I'm trying to get an exponent and I see radicals, I want to turn this radical into an exponent. So let's make this 25 to the 1/3 power. And if I'm trying to write it as 5 to a power, I think I can change that 25 into 5 to the 2nd power, agreed? And then I know my rules of exponents, power to a power, we're going to multiply those together. So that's 5 to the 2/3. So my exponent is 2/3, which means my answer is 2/3. So that's one way you could show work for that. My personal favorite way to show work for these is to basically do the same thing, but try and get my bases to cancel. So I would basically do the same thing. I'm just going to keep writing equals. So that's the log base 5, and I'm going to rewrite this as 25 to the 1/3. And then I'm going to change my 25 to a 5 squared. And then I've got log base 5 of 5 to the 2/3. And if I can get it to this point where the base matches, the log base and the exponential base match, what happens to the log and the exponential? Whoosh, they cancel each other out, and we're left with just 2/3 for a final answer. That'd be another way to show work. Either way is fine. I don't really have a preference. Yes.
Would you like to include all those steps, or could we skip?
I'd say in a problem like this is really about showing your understanding. So yeah, I'd like you to show steps. Yeah. When we get to the test and you're doing something like that, I'd like you to show me all your steps. If you have it, and there are other ways that you can tackle these and think about them. So if you have kind of a different method, let me know, run it by me, and I'd be happy to look it over. I saw someone doing this as well. So third way to do this. Log base 5 of 5. What I saw some people doing was setting this thing equal to x and then turning it into an exponential equation. Do you guys remember how that works? If you have an equation that's in a log, this is in a log form. Do you know how to turn this into an exponential form? This is important. You're going to need to know this. Regardless of whether you choose to do the problem this way, you're going to be asked to do this on other problems. So what I think about is the 5 comes over. That's my base. It's going to come over. Remember, the log is an exponent, so that x is going to become my exponent. So I would have 5 to the x over here, and it's trying to be a 5. And then Q rid of 25 over here. And then you can work to try and get 5 to the 2/3 equals 5 to the x. And when you get to that point, you can get rid of your bases and just say x is equal to 2/3. So that's a third way that you could do it. There's probably another dozen or so. Let me know if you've got a different method. Run it by me and I'll give you some feedback on it. Thank you for that question. Were there any others from that was from the 3.3 homework on page 308? Anything else we can talk about from that assignment? Okay, yeah, so the log of -42, okay. Can we do that? Let's try it. Let's try it. Let's practice what we just did a second ago. I'm going to set this equal to x. What's the invisible base that I did not write on my log here? 10. So if I wanted to turn this into an exponential, I envision this 10 coming over and bumping that x up. So we get 10 to the x equals -42. So I want you to think, can I take a positive number and stick an exponent on it to turn it negative? Is there any number of times I can multiply 10 by itself? So the positive 10 by itself so that it's going to turn negative? No, that's just not possible. So x, this would be undefined. We would say this is undefined. What if I changed it, so instead of -42, it was 0? Can we take the log of 0? Is there any exponent that I could put onto a 10 and make it equal to 0? No. What about 1? I can think of an exponent I could put on a 10 and make it equal to 1. 0, right? What's the log base pi of 1? What is the exponent you can put onto pi to make it equal to 1? 0. What is the log base anything of 1? 0. Well, we can't do a base of 0. That's where the rules fall. You're right. The log base 0, if we allow that to exist, would have a different answer. That's why we don't allow it to exist, though, because that would cause inconsistencies. We don't do 0 to the 0th power. Do you guys know why not? This is interesting. I think this is interesting. A big part of mathematics is being able to hold two different ideas in your head at the same time. In fact, I would say that a large part of life is being able to hold two different ideas in your head at the same time, right? Sometimes conflicting ideas. We don't like it in math, but we kind of toy around with it sometimes. So here's a pattern for you. 3 to the 0th power is 1, and 2 to the 0th power is 1, and 1 to the 0th power is 1. So if we follow that pattern, then 0 to the 0th power would be 1, right? But here's the problem. 0 to the 3rd power is 0, and 0 squared is 0. 0 to the 1st is 0. So by that logic, 0 to the 0th power would be equal to 0. So we can hold these two patterns in our heads at the same time, but we're getting two different answers for it. And we don't like that. So once we compromise and go with a half, I like that. That might work in other realms of our life, but no, we don't do that in math. We kind of sweep it under the rug and say it doesn't exist. Okay, that's where undefined comes in. When you kind of have two different ideas that are both logically correct, but we're ending up with different answers. When we get that kind of conflict, we say it's undefined. All right. Any other questions from our homework? I want to talk time frame with you guys. All right. So let me start